Okay, what we're going to start on now is a brand new unit of study. So we're all done with the geology information, so we're going to move on to our next big unit of study, which is going to be meteorology, which is the study of Earth's weather, composition, severe storms. We're going to get into a lot of unique and interesting weather phenomena. So the first set of notes that you're going to look at goes along with chapter 28 in your text, and it's just titled Earth's Atmosphere. So as you look at this, yours is just on one page. I've enlarged it so you can see it a little clearer on VoiceThread here. So part A, atmospheric composition. Number one, the atmosphere surrounding the Earth is a mixture of solids, liquids, and gases. Now, obviously gases are pretty simple. I mean, you can think of what the different gases are, but as far as liquids, what liquids are there in the atmosphere? Well, mainly and mostly that would be water vapor or suspended water vapor in clouds, rain falling as liquids. Now, solids is a little bit tougher. What solids can you think of that exist in the atmosphere? So I usually get responses from kids right away like meteorites falling, from space. Now, that's okay, but really what it means by solids in the atmosphere are tiny particles of dirt and dust, volcanic ash. Those would be solids in the atmosphere. Number two focuses on specific gases in the atmosphere because that tends to be what we think of with the atmosphere. So mostly what you breathe in, most of what Earth's atmosphere is 78% nitrogen. So every time you suck in and then breathe out, it's basically nitrogen. Nitrogen doesn't really do anything for the human body. We breathe it in, we breathe it right back out. Letter B, then, 21% of the atmosphere is what most people think of, and that's oxygen. So it's not like it's the biggest number, but obviously oxygen is very important to us. 0.93% argon. Now, argon is a poisonous gas, so fortunately argon floats up higher in the atmosphere above where people breathe. Letter D is carbon dioxide. So CO2 is found in 0.03%. Now, unfortunately, that number is slightly rising, and it's one of the major contributors or causes of global warming. And there are trace amounts of other gases. Number three, biological processes. Living organisms change the concentration of carbon dioxide and water vapor in the atmosphere. So humans, like I said, are kind of having a negative effect on carbon dioxide increase. Number four, Earth's atmosphere is a delicate balance then between what's forming and what's being destroyed. Think about that. If plants, which make their own food, are constantly making oxygen, then why isn't our planet getting more concentrate, greater than 21% with oxygen? That's because as the plants create it, humans, other mammals, other organisms are using it up, and we respire carbon dioxide. So there is a delicate balance, again, between what's absorbed and what's given off. Okay, as far as how the atmosphere is structured then, like if you go outside and look above your head, how is it exactly organized? Well, number one, the closest layer to the Earth's surface, the layer that you walk around in, the layer you climb trees in, the layer that airplanes fly in, that's called the troposphere, T-R-O-P-O sphere, S-P-H-E-R-E. Number two, generally temperatures drop as altitude or height increases. Now think about that. That's kind of weird because the higher and higher you climb a mountain, the closer you're getting to the sun. So you would think getting closer to the sun it would be warmer, but that's not the way it is, right? It gets colder the higher and higher up you get. So why is that? Why is it that the higher up you go in elevation, the colder it gets? Well, the answer to that has to do with the air. Most of the air, most of the gases of the atmosphere are right here, right along the surface, nice and close. They absorb heat, the heat that we feel. So the higher you get in elevation, the less air there is, the less heat that those air molecules can trap or hold. So it does get naturally cooler the higher and higher you get. So temperature inversion is when temperatures increase with height due to the gases present then. All right, number four, the second layer of the Earth is called the stratosphere, S-T-R-A-T-O sphere, S-P-H-E-R-E. Stratosphere is rich in oxygen. The next two layers, the middle layer is called the mesosphere, M-E-S-O sphere, S-P-H-E-R-E. And the fourth layer is called the thermosphere, T-H-E-R-M-O-S-P-H-E-R-E, thermosphere. And the outermost layer is called the exosphere. Exosphere is what enters into outer space. How is the atmosphere heated then? Well, number one, the energy that heats the atmosphere mostly comes from, obviously, the sun. So the sun is blank, number one. Solar radiation that reaches the Earth's surface is either absorbed, A-B-S-O-R-B-E-D, or it's reflected back into space. About half, about 50% of all the sun's solar radiation reaches the Earth is actually absorbed. Number three has actually a couple definitions. It says it's the re-emission of radiation back into Earth's surface. It's also defined as the trapping in of heat due to carbon dioxide gases in the atmosphere. Number three, the blank, is called the greenhouse effect. And greenhouse is something that traps in heat, so that's why it's called the greenhouse effect. Number four, conduction. Convection is the blank, C-O-N-V-E-C-T-I-O-N, and latent heat, called radiation, all add to the heating of the Earth's surface. Now think about this too. The Earth's surface is not even heatedly because it's varied and it's not uniform. Think about this. The world is round, so the sun doesn't strike the world at the same angle. That's why the equator is much warmer than the poles. Plus, we've got mountains, we've got hills, we've got valleys. All those uneven surfaces add to the fact that Earth's surface is not heated evenly. All right, so that completes this set of notes. Again, you have to scan and copy it, and you can turn that part in for me for a grade. There's a video assignment to look at, and there's actually another section of notes that also goes along with this section.